N2O5 is an important nighttime reservoir for NOx. During the night, the heterogeneous hydrolysis of N2O5 on aerosol particles is considered as a possible pathway for NOx removal and leads to nitric acid formation as well. The reaction rate of the hydrolysis of N2O5 on aerosol particles can be quantified by an uptake coefficient called gamma. Current models use the bulk composition of the particle population to calculate gamma. Well, you can say this is appropriate when the aerosol is internally mixed, or we can call this population has an average composition, which means for each particle, no matter if it's big or small, they all have exactly the same chemical composition. In this case, the population gamma is the same as particle resolved gamma, independent of particle size. But what if the aerosol has a more complex mixing state? For example, you collect a sample from the ambient air. The sample includes combustion particles, sea-spray aerosols, road dusts, and secondary organic aerosols. Clearly, the chemical composition of these particles can have differences. In this case, the population gamma can no longer be the same as particle resolved gamma. Another thing we care about is the morphology of particles. According to the past experimental studies, there are at least 3 mixing structures of organic aerosols. It could be a core shell structure, just like the peach I've shown here. The kernel is made of inorganics, and the pulp is made of organics. It can also be a partially engulfed structure, meaning that the core doesn't have to be in the center. And the third structure is called a well-mixed structure, meaning that the organics and inorganics are mixed together, so there is no clear phase separation between the two. To answer the question of which factor influences the N2O5 hydrolysis rate more, we can compare the 3 different population gammas. Gamma PR represents the actual composition and mixing structure of particles. When comparing gamma PR and gamma CA, we can know if the composition can actually make a difference in N2O5 hydrolysis rate. And when comparing the differences between gamma PR and gamma mix, we can see if the morphology will influence the hydrolysis rate. If the gammas have significantly differences, it will ultimately lead to a different prediction on the concentrations of species related to this reaction, such as ozone, NOx, nitric acid, and N2O5. But if the differences are negligible, well, then it's a good news, meaning that it's okay to make simplification in our model. Thank you.